Hello everybody and welcome to Bowtie Teacher. I'm Rob and in today's video we're going to be looking at the Year 7 test in October. Let's get started. So as we can see here, we have the different topics that will be assessed in the test, and we're going to go through each one with some examples and some practice questions that you can do and to support you with your forthcoming assessment. Okay, so the first topic we're going to look at is the types of number that we'll be dealing with. So the numbers that we will be looking at are the square numbers, triangle numbers, and the cube numbers. So you need to know the first 10 square numbers. So 1 is 1 squared, 4 is 2 squared, 9, 3 squared, etc. up to at least 10 squared. So you should be able to recognize all of those in, for example, a list of numbers. You should be able to pull out all of the square numbers, and if you know the first 10 or 12, then you're in for a good chance of answering these questions. When we're looking at the triangular numbers, we're thinking 1, then we have 3, where we put our dots like this, 6, you're just building up the layers in this fashion. 10 is the same again, and you can see that the difference between each are going up in 2, 3, 4, 5, so the next one would be 15 and then 21 like this. So if you remember that 1 is the first triangular number and that you're going up in 2, 3, 4, then you'll actually know all of the rest. But try and be able to recognize these so that you're not wasting time in the exam trying to work these out. Cube numbers, we have the first 5 we should be aware of. So 1 is 1 cubed, 8, 2 cubed, 27, 3 cubed, 64, 4 cubed, and 125 is 5 cubed. Okay, so let's test ourselves here. Let's put some random numbers on here. Just try and pause the video and see if you can pull out all of the square, triangle and cube numbers from that list. Okay, so I hope you had a chance to do that. Let's maybe highlight some of these. So I'll do the square numbers first. So we're looking at 1, 4, 9 and 16. Okay, next one would be 25, which is too big. Then we're looking at the triangular numbers. So 1, 3, 6, 10, 15, and the next one would be 21. And the same for the cube numbers. Let's just do that in yellow. So we have 1 and 8. Okay, so hopefully you can see from there that we need to learn these so that in the exam you can be really quick and not waste any time trying to work these out. You can just recognize, for example, 64. Okay, that is an example of a square because it's 8 squared, and it's a cube because it's 4 to the power of 3, like that. Okay, so try and test yourself with the first 5 cube numbers, the first 5 or 6 triangular numbers, and the first 10 or so square numbers. The next topic that we're going to be looking at is Bidness. So remember, Bidness is the order of operations in which we do calculations. So you might see something like 4 plus 3 times 7, and you read this from left to right, you'll get 4 plus 3 is 7 times 7 is 49, right? Well, actually, we should be doing the 3 times 7 first, okay? Because multiplication comes first in Bidness before the addition here. So we're actually going to do the 3 times 7 first, and then we're going to add 4 to that to get 25. If we had something like 2 minus 3 times 6, then we would be doing the 3 times 6 first, and then we would do the 2 minus 3 times 6 is 18. So we'll have negative 16 in this case. And the negative numbers, we will be assessing you as well. So what about something like 4 plus minus 3? We would be looking for you to look at the plus and minus that are kind of bunched together here. And if the signs are the different, like plus and a minus, then we're going to get a negative sign. So the same sign would turn into a plus, and a different sign would turn into a minus. That's only when the two signs are connected like that. So if we had 4 minus 3 like that, then officially there should be brackets around these, but if not, then these two signs here are touching, they're connected, and they're the same sign, so the two minuses would turn into a plus. Try not to confuse this with something like minus 4 times minus 3, and students think, well, minus and a minus, yeah, that does become a plus, but they're not connected to each other, so it's a slightly different rule, and we shouldn't try and get confused. This is only when the signs are in contact like this. Okay, you might be required to do something like 3 plus 4 plus 5 times 3, and you could add some brackets to this to try and get certain numbers. So let's say we wanted to get 30. Would you be able to put some brackets around some of these numbers which would encourage us to get 30? So if we put brackets here and here, you get 7, which we would work out. 5 times 3 we would do next, because we would do the brackets first, then the multiply, so 15. 7 plus 15, no, that wouldn't work. You would have to try different combinations and see if you can spot how you would do this. Maybe pause the video here and see if you can work out what to do. So if we put brackets here and here, we have to do the 4 plus 5 first to get 9. So we have 3 plus 9 times 3. We would then do the multiplication next. So 9 3s are 27. 3 plus 27, yeah, that does equal 30. So those brackets would work. Okay. Next up is indices. This is a topic that students generally struggle with. So if you can try to nail these and make sure that you can do them in the exam, that will be really beneficial to you. So we might have something like 3 cubed times 3 to the power of 4. If the two large numbers here, the bases are the same, then we can apply the indices rules, which is to add the powers to get 3 plus 4 in the power, and 3 to the 7 will be the final answer for this in index form. Okay, in index form. So 3 to the power of 7 is the index form. If we were to do something like 3 squared times 3 cubed, and we get 3 to the power of 2 plus 3, which equals 3 to the power of 5, this is also in index form because we have the power there. If the exam asks you for the value of this, then we would have to actually work out 3 to the power of 5. Now this is a non-calculator paper, so we wouldn't be expecting you to work out 3 to the power of 5, but you might have something like 3 cubed, and you should know from the earlier work that we talked about, 3 cubed is 27. So 27 is the value, and 3 cubed would be the index form. So make sure you know the difference between those. When we're dividing powers, we might have something like x to the power of 7 divided by x cubed. We have the same base, so we can subtract the powers. 7 minus 3, x to the power of 4, like that. The last two rules that always stumps the students in the exam, x to the power of 0 or 5 to the power of 0, or any number or letter to the power of 0 always gives 1. Not 0, 1. Make sure you learn that rule. And also, 5 to the power of 1, that's just 5. X to the power of 1 is x. Anything to the power of 1 is itself. So make sure you learn these two index rules, because they are the ones that confuse students. And we may, as an extension, or try to push some of you, look at something like x to the power of 7 times x cubed divided by x to the power of 6. So the top of this fraction is x to the power of 7 plus 3, because we're adding the powers. And this slash here, this is a divide sign. So divide x to the power 6. X to the power of 10. We're now dividing these powers, so we subtract and we minus the 6 to finally get x to the power of 4. So that's about as hard as it's going to get for you guys. Make sure you learn these rules and apply those in situations which are slightly different, like this, but you can see that you're applying these rules in a slightly strange way, problem solving. Okay. Finally, we're going to be looking at HCF and LCM. So we're talking about the cherry trees, right? Let's say we have 100 and we want to express 100. This is how it would be worded in the exam. Express 100 as a product. What do we mean by product? That means multiply. So remember that for later. A product of its prime factors. Okay. Now notice in this question, we're not saying, oh, do some cherry trees. It's actually quite a nasty worded question, but product means multiply. Prime factors, we're looking for factors that are prime numbers. So let's break down 100 into its prime factors. You can start with 2, is usually the easiest. 2, and then 50. So 2 times 50, they pair up. You can carry on with 2, and 25, and 5, and 5, like that. So when we hit a prime number, we stop. And notice that they kind of look like cherries there, so hence the name. So the final answer would be 100, because we want it as a product, so we have to multiply all of these prime numbers together. 2 times 2 times 5 times 5. Let's check that. 2 times 2 is 4, times 5, 20 times 5. Yep, that's 100. And put it in index form. 2 squared times 5 squared. Okay? We'll do that again with another number, 120. Try and pause the video and see if you can actually do 120 as a product of its prime factors. Okay, I hope you had a chance to do that. Let's see, 2 and 60, 2, 30, 2 and 15, 3 and 5. I'm just going to, you don't have to do this in an exam, I'm just going to highlight the primes for us. 2, 2, 2, 3 and 5. So 120 is 2 times 2 times 2 times 3 times 5. In index form, 2 cubed times 3 times 5. Like so. Okay. Now, once we've done this process, we can then start to look at the highest common factor and the lowest common multiple. So, let's just get this here in black for us. Okay, so we had 100 and 120, and 100 was 2 squared times 5 squared, and 120 was 2 cubed times 3 times 5. We can use a Venn diagram for both of these. Let's put 2, 2, 5 and 5 for 100, and for 120, we're going to have 2, 2, 2, 3, and 5. Now notice that there are some that are appearing in both. So if we have them in both, let's just scratch that out there and put it in the middle, because there is a 2 in each of these. There's another 2 here. There's a 5 in both. And then the rest of them are by themselves. Okay, so I'm just going to score these out so that they don't get confused here. Like that. Okay, so on the left hand side for 100, we've got the 5, 5, 2, and 2 still, and on the right hand side we have 2, 2, 2, 3, and 5. I hope you can see how they kind of work with the Venn diagrams. So the HCF is simply the highest common factor is those numbers in the middle multiplied together. HCF equals the 2 times 2 times 5, which is 20. So 20 is the largest number that goes into 100 and 120. The LCM is going to be all of the numbers multiplied together. So we've already done 2, 2, and 5, so let's use that. So we've done those 3 in the middle, and we just multiply that by whatever's left over. 5, 2, and a 3. That gives us 20 times 5 is 100, times 2 times 3 is 600. So LCM is the lowest number that appears in both of the times tables for these. 200, 300, 400, 500, 600. And 120, 240, 360, 480, 600. So 600 is the first number that appears in both of those times tables. Okay? Now, if you're wanting to practice some of these concepts, then you can go over to bowtieteacher.com, and I've made an app called GCSE Mathematics, but actually there's some of these things that are assessed at the GCSE in the same way. So we'll click on GCSE Maths, and if you want to log in and save your progress, you can, or you can just press Start, and in the level 3 for GCSE we have prime factor decomposition. That's kind of like the mathematical name for this process. So let's have a look at, say, 150. 150, you would do your cherry trees, you break it down to 75, 3, 25, 5, and 5. So we would do 2 times 3 times 5 times 5, and you can check your answer and see that that's correct. I might just maximize that so you can see it a bit better. And you can keep practicing these as much as you like. Okay? 60 is 2 times 30, so 30 is 2 times 15, 15 is 3, and 5. So you're starting to see how to do these. And then if you go back to level 4, HCF and LCM, it's giving you 2 numbers here to break down into their prime factors, 225 and 84, and start to work out the HCF and the LCM. So this app here that I've designed will allow you to practice these 2 concepts as much as you like. You can also use other websites online, but this one can get you started on these processes. Okay, so I hope that was useful for you. If you have any questions or comments, please put them below, or you can email me at mrwakeling@bowtieteacher.com. Good luck, and I wish you well in your exams.